Welcome to a lesson with Dr. Powell. Let's take a look at hyperbolic, trigonometric functions. Okay, we now have trigonometric functions, and trigonometric functions, like cosine and sine, parameterize a circle. Namely, we can plug in something here to cosine and sine and have coordinates on the unit circle around. Now, what is theta? Theta is arc length on the unit circle from here to here. But it is also, but theta is also equal to twice the area of this guy, or if we just went like this, it's equal to this area right here. And that's because the area of the unit circle is actually pi, is pi. So if you were to twice an area, you would actually get, you'd actually be on your way to 2 pi, and that's what, and we're looking at equivalent fractions all around the circle, and perimeter circumference goes all the way around 2 pi. So this you can actually check if you want, but if you take this area, the area of this sector and the area of this one, it's equivalent to this arc length on the unit circle. So we could think of theta as simply being that. Now for these guys. All right, let's not think about the unit circle. Let's think about the unit hyperbola. So the circle is contained in the unit box with a radius of 1. Unit hyperbola, this one in particular, is contained out here with asymptotes like that down the diagonals of the unit box. Unit hyperbola. But let's only focus on this part of the unit hyperbola over here. Now, if I take a coordinate, I can actually parameterize this by something called cosh, or hyperbolic cosine, but I'll just call it cosh. Cosh of, and I'll use t, and sinh of t. All right, and that can parameterize that point where t happens to be, so if I take a line and I go right to the origin right there, the center, just like I would for a circle, but right from here to here, fill in this area, and then I double the area to here. That's actually, just like what I did over here, that's actually what t is. So if I plug in that into the cosh and the sinh functions, I end up getting this parameter right here. So that's what we define cosh and sinh to be. Now, a nice way of describing what cosh and sinh are as follows. I could say cosh of x is equal to cosine of I times x, yes, where I is a square root of -1. And sinh of x is equal to, sinh of x is actually going to be equal to the derivative of this. And you can check to see what the derivative of this is. It's -I, using the chain rule, thinking of I as a constant, -I times the sine of ix, because the derivative of cosine is negative sine. So you can take these as definitions for cosh and sinh. There are alternative definitions, which can be used using the e to the x function. For instance, we could think of this as being we can think about this as being so cosh, another equivalent definition, is simply e to the x plus e to the -x all over 2. And sinh we could think of as e to the x minus e to the -x all over 2. But these definitions over here are great for establishing identities and thinking about derivatives. Thanks for watching.